Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNSEs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us, and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. Okay, so the first question is, what is Docker? Okay, so when I look at it, I see the Docker is doing nothing but managing the container. So I will call it container management tool. It's a tool. Now, when we say tool, okay, so then of course there must be some benefits out of it, right? So what kind of benefits which we have using this tool? So when I look at this tool, it this tool will help me in saving cost, okay, then saving time also, and then uh, improve improving in terms of quality of work, which will help me to improve. Now this I'm not able to understand how a tools which is Docker can save cost, how it can save time, and how this can save to improve my quality of work. So that things I want to understand. So when I say saving cost, see, you have to think in this way. You want to run applications, and you want to run applications in data centers, let's say. Okay, though you can, this logic will apply for running the application in a development environment also, production environment also, right? Many use cases, but think of it like you want to run applications. Which applications? Like Apache, Tomcat, database, your product and all, and in a data center, and there we want to save cost. Let's say we have to run more applications for the traffic which you are generating, your application is generating. And then what about if I run the same application with lesser cost? Lesser cost means lesser CPU, less RAM, and hard disk, and no operating system cost sort of it. Then of course it's going to save loss of cost, right? So let's say I have a 10 GB of CPU, and earlier I was able to run uh, 5 application. I'm just giving you some scenario, and with a Docker I am having 10 CPU. Let's say 5 applications you are able to run. Now with the help of Docker, let's say if you have a 10 CPU, then you are able to run 10 applications. So think in this way. So you are saving cost. Means if you run an application with the help of Docker, this will save your cost. Okay. So this way it will help us. Now saving time, which way? So I'll put it in this way. Let's say nowadays we don't run application in a physical server, but we run application in a virtual server. Virtual server means cloud, uh, AWS, Azure, or VMware or something like that. So cloud session is pending, so I'll have that as well after this. So how much time it takes to set up application? So let's say 5 minutes using the VM, and from the 5 minutes now using Docker is taking 1 second. So here you are saving time, correct? Here you are setting up, creating application, running an application in 1 second. Earlier you were spending 5 minutes for it. So you want to run thousands of applications. So 1 second is like that. Okay. So this way you saving a time, and when you save a time a lot, then of course you will get a lots of time where you can spend your precious time on the quality coding and quality testing. Earlier the same time you are spending on the dev environment setup, QA environment setup, all this thing and all. So integrations, also when you do the software development, lots of integration is taking place, and for that you do the spend the time, and that you are saving here now, and you can spend on the good quality code and testing. So now this is the tool. Okay, so if now if someone will ask me, okay, why we are using Docker, are we having the answers for it, all of you?
Hmm. Saving cost. Yep.
Hello. Hello.
Yes, sir.
Yes, sir. Yeah, but there's still one question is not, I did not understand, and that is, what is container then? Because here I can get all this benefit only and only if that what if I understand container, and this topic is very important, and this will take some time also to understand. I'm not, expecting that to answer these questions immediately, but yeah, slowly, in this session also, and then a Linux session also, many times we'll understand this question slowly. But for time being, what is container? Okay, so what is container? So this is something which we need to understand. So how do we start this? So what I would say, what I would suggest, forget about the containers right now. Don't try to get an answer for what is container. Try to get an answer for how applications can be run. That is that should be the right question, because ultimately here all this thing you are running application, right? So how application can run? What are the resources you need to run any applications? I repeat, what are the resources you need to run any applications? For example, if you're getting confused with my questions, mm, these are the applications which I'm running in my laptop. Okay, and where is a detailed view? So UI has changed a little bit of it. Hmm. So this is the detailed view. Are you comfortable with it, this task manager,
Yeah.
all of you? Yeah. So I don't know how many of you have noticed, but if I ask you, what are the applications you need to run any application? So here, these are the applications you have. See how many Chrome I'm running. Okay. So multiple Chrome I'm running, and see so many software. Firefox also so many. So if you are saying, hey, this is the only one application Chrome, no. Chrome 1, Chrome 2, Chrome 3, Chrome 4, like that. So many Chrome actually is I'm running in my laptop. So if I see this is a one applications, and here if you see that username, every application is running with certain users. System user, Rajesh Kumar user, and you see, do you see that anywhere is blank? User is blank? No. Local system, Rajesh, network user. So all services running with the user. So that one thing is sure, you need a user for running an application. These all are applications. And then you need CPU also. you need RAM also, and then you need a PID also, PID allocations. Agree with me, all of you?
Yes.
Yeah. So this is something which I am trying to you to think about it. So if someone asks you, okay, what are the resources we require to run any application? One application I'm talking about, okay? Only one application, not every application, because rules will be applied same for everyone. So first I need hardware, of course, need hardware. And then you need operating system. Now, if I ask you what is there in operating system, anyone have answer? Operating system?
Like Windows, Linux, on which we can install our softwares.
Yeah. So we have a kernel, right? So every operating system you have a kernel. There is a two kernel in the whole world which we use it. Linux kernel using that CentOS, Ubuntu, Fedora, Debian, Kali and all it has been developed. And Windows kernel using that Windows 10, 11, 12, 13, 14 and all it has been developed. So yeah, hardware and then kernel. And when we kernel, what is a kernel? So kernel is just some computer program, okay? And kernel have different types of module in kernel, you can say. So what are the modules? So we have a namespace, we have a C groups, okay? We have a capability. These are the different type of program which we have. Now, in order to simplify this, Docker namespace, I'll show you the image, you will understand better. See here, see here, just focus on this part, kernel, C groups, namespace, SC Linux, capabilities, and many other stuff. So these are the Linux kernel. Okay. So hardware, then kernel, and then these are the resources. Now you'll say, Rajesh, why you are talking about all these resources and all? So I'm talking about these resources. Why? Because this namespace, we have a few kind of namespace like a PID namespace, user namespace. Again, I'm talking about the kernel level, okay? PID namespace, user namespace, network namespace, and one MNT namespace. So these are the four. Many other are there. I'm not teaching you kernel in detail, but at a high level. So at least this question can be answered. So these are the namespace we have. Now, what is the PID namespace is doing? So PID namespace create one PID map in the PID tree, you can say, in the system. PID tree means what? PID tree means the one which we have. Look at this here. This is the PID middle one. If you, this is the one I'm talking about. So this is one PID tree starting with a zero. You want to go trace to that? See here, starting with a zero. Are you able to understand that, right? Hello.
Yes.
Yeah. So this is called PID tree. Now next one is user. So this one create a user. This user namespace create a user. So here you see that user Rajesh, system, local and all user. Now this one create a network. So application can be accessible over the network. Okay. And this MNT basically, I don't want to confuse you. This is a root file system. Plus application system, app file system. Now you will say what is a root file system, what is app file system. So there is a four types of file system you have in the operating system. Always remember this is something generic topic which we might have studied in colleges also. Second semester system architecture and design. So here file system. So one is a boot file system. Boot file system is like kernel. Plus on top of that we have a root file system. Boot file system which is kernel, and then root file system, I'm not able to understand that. So let me try to see that here, root file system. And here Have you seen this kind of structure anywhere? Anyone? This kind of structure? Anyone? Have you seen it?
No.
No. Anyone have worked with Linux? No. Okay, so not to worry. We'll start working on it. So, okay, at least this year probably you may not have seen it. Have you seen this structure? This structure in Windows where you have a C drive and then this structure have you seen, right? Yeah, everyone?
Yes.
Yes.
Yeah, this is a root file system. A file system which you can consume and see. Start from my PC here. This is a root file system, and then C drive, program files, all these are root file system. In Linux, this is the one actually. So here there are four types of file system: boot file system, root file system, user file system. User file system means what? Only users can see. This is my desktop. This is my user file system. Belong to Rajesh. If some other users will be there, let's say Raju. So for him also, something similar will be created, but it will not be same. Similar, but the content will be different as per his what he's storing it. Okay, and then application file system. Application file system means some application which is installed in your root file system. So let's say I install all of my application in C drive. Program files also, you remember that. So this is my application file system, directory and files. So this is a Maven actually. So these are the four file system what you have. So when I say mount means this is the root file system and plus application, not a boot. Are you understanding, all of you?
Hmm.
Okay.
Yeah.
Now come back to the question how apps can be run. So in order to run your app, you need a hardware, then you need a kernel. Kernel has namespaces. These are the namespaces you need it. These are the C groups. C groups allocate the CPU and RAM. Okay, and then capabilities assign the permission to the user. So these are the resources it can be used to run any applications. Okay, let me create some diagram so visually you can remember that, and slowly you will get this topic because kernel, I don't know how many of you got comfortable with it. So this is my hardware, and after that this is my kernel, and kernel you have all these resources which you see that here, namespace, C groups. I'll show this picture, it'll be easy for you. This one, C groups, namespaces and all. And after that what happens then, how many I'll ask this question, you will have to answer. How many mount you have seen in the one operating system? Now if I ask you mount, then you will get confused. So if I ask you how many C drive you have seen in one computer, tell me how many?
One.
Only one. So that is mount actually. Okay, mount means root file system and app file system. So only one. So let me create one mount actually, you only said. So one mount. Okay, this is the mount. How many PID tree you created starting with a zero? So only one. Means PID ID is a separate, but if PID tree is one and starting with always zero. So here tree also, and you want that application networking also, so one network. So if you see that here, there's a one PID tree got created starting with a zero, and then one mount, okay, mount, and one mm, I see, I forgot this, mount network, one network, okay. And on top of that, what happens? How many users you can create in one operating system? All of you?
Multiple.
Multiple. So this is the one user, this is the one user, this is the another. You know, here all these three, this is Rajesh, this is Jamie, this is Patrick. So all these three user is created on this compute unit in your laptop or in your VM or something like that. Now applications can run like Apache. So this is Apache running on which port? Anyone have idea which port Apache web server running? 80 port, correct? So yeah, can this guy Jamie can run Apache on 80 port? 80 port here
No, sir.
I run 80 port. This 80 port, this 80 port, can he run?
No, sir.
No. Why? Because of what is the reason? Port has been already allocated, but technical word is you have only one networking assigned, so you cannot use the same port again and again on the same network. Correct now? So not allowed. Now see here, this Apache is running with a 50 PID, 50 PID. Now this Apache and this Apache can they claim the 50 PID? No. You saw that here. You see, always unique PID come from the pit tray. Look at this. And in my system is running from last night, and that PID has reached to 25,000 something. So create, destroy, create, destroy, create. These are the application which is running. So PID you can see. Those who exited the application, you cannot see the PID. Okay, it's always incremental. So can you run the same PID? No. Can you have, so I am storing the Apache in C Apache, simple way. So Jamie, can he store the same Apache in same location? No. So here there is a problem. If you want to run three application, this is your laptop, okay? You cannot run three Apache. You can run Apache, Tomcat, or some other application, different port, different location, but you cannot run three Apache. Same port, same PID, same mount address. Are you understanding, all of you?
Yes.
Yeah.
Okay.
Yes.
So if you have understood that, and that is the problem which we have in the data center. Whatever the compute unit you have, understand that whatever the compute unit had you have, in order to run your operating system, in order to run one applications, only one Apache we running in the data center, you need one operating system, and this is also 1111, and you need one user and then one Apache. Agree with me, all of you? In a data center, we don't run too many applications. One operating system, one PID, one mount, one network, one user, one applications. Right? Sorry. Understood, right? Hello.
Yes.
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 So now the question is what is the waste in this whole architecture? What is waste? So simple way. I want to run in data center one application. I need one OS. If someone will ask you, hey, why you are not able to run multiple application in data center in one OS? Reason you have it. You cannot run on the same port, same PID, same location. So that's the reason we always what we do. You want to run 100 Apache, 100 VMs we create. You want to run 100 Tomcat, 100 VM we create. If you want to run 100 MySQL instance, 100 VM we create. Understood, right? So 100 VM means 100 operating system. 100 Apache means 100 operating system, and each operating system also, mind it, each time operating system also consumes CPU, RAM, storage, and licensing cost. That means if I want to run 100 Apache application, that means 100 operating system, and this 100 operating system I have to buy it. I have to pay for the CPU also, the running operating system, running RAM, I mean running for running operating system RAM, and then storage and so on. So that is the problem actually in data center, not in your laptop, but in a data center where we are running millions of applications. Think about the scale, okay? Millions of applications we are running, so that we need millions of operating system, and millions of operating system also it required lots of infrastructure to run. Correct now? Are you able to visualize in your mind?
Yeah.
So we want to save cost actually. We want to save operating system cost. And that is the reason we decided we migrate to container. But the question is again, what is container? I don't understand. So what will happen? There is a one guy I want to show you, Solomon Hikes. Okay, he's the guy. See here. Now, what he has proposed, in fact, not only he, I know many people have proposed from last 20, 30 years this model, the one which I'm going to discuss. But this guy has implemented it. So that's the reason we can say father of Docker. Okay. So what he is suggesting, think very simple way. In order to run any application, you need one PID, one mount, one network, and one user. I repeat, in order to run any applications, these are the four resources you need. Agree with me?
Yes.
Now, who's creating it? Kernel. Now, this user, this is I'm inside, okay? Just like I've logged into my laptop and I'm showing you one application which is called Paint. So I'm inside. I'm inside, okay? This is inside. And when I'm inside, I will see that this C drive, not this C drive. I will see my C drive, which is separate from this C drive. I will see my own PID and my own network. Okay. So now think simple. In order to run any application, you need user, mount, PID, and network. Same time, how many network can be created by kernel? Unlimited. It's object, it's a code. You can run multiple times. How many PID tree can be created? Unlimited times. How many mount you can create? How many C drive you can create by kernel? Unlimited times. How many users you can create by kernel? Unlimited times. But actually, operating system companies like Microsoft and Linux, what they do, they create only one network, one PID tree, and one mount. Why? Because what you'll do with the multiple C drive, you'll get confused. So kernel has a capability to create it, but we don't create it. Why? PC concept, personal computing. The computing which your model which you're using is a PC model. That means it's designed for the user, not for running a data center. So user is using compute unit in a different way, but in a data center we need a compute unit in a different way. But what has happened gradually over the last few years, we are using PC model itself in a data center to running an applications. That is a problem.
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.